Hello and welcome everyone to another podcast. Today we'll discuss on Chandrayaan-3. The mission will launch hopefully on 12th July 2023. So let's begin. Chandrayaan-3 is a follow-on mission to Chandrayaan-2 to demonstrate end-to-end capability in safe landing and roving on the lunar surface. It consists of lander and rover configuration. It will be launched by LVM-3 from SDSC SHAR Sriharikota. The propulsion module will carry the lander and rover configuration till 100 km lunar orbit. The propulsion module has spectropolarimetry of habitable planet Earth shape payload to study the spectral and polarimetric measurement of Earth from the lunar orbit. Lander payloads. Chandra's surface thermophysical experiment to measure the thermal conductivity and temperature. Instrument for lunar seismic activity for measuring the seismicity around the landing site. Langmuir probe to estimate the plasma density and its variations. A passive laser reflector array from NASA is accommodated for lunar laser ranging studies. Rover payloads, alpha particle X-ray spectrometer and laser-induced breakdown spectroscope for deriving the elemental composition in the vicinity of landing site. Chandrayaan-3 consists of an indigenous lander module, propulsion module and a rover with an objective of developing and demonstrating new technologies required for interplanetary missions. The lander will have the capability to soft land at a specified lunar site and deploy the rover, which will carry on in situ chemical analysis of the lunar surface. During the course of its mobility, the lunar and rover have scientific payloads to carry out experiments on the lunar surface. The main function of PM is to carry the LM from launch vehicle injection till final lunar 100 km circular polar orbit and separate the LM from PM. Apart from this, the propulsion module also has one scientific payload as a value addition, which will be operated post separation of lander module. The launcher identified for Chandrayaan-3 is GSLV-MK3, which will place the integrated module in an ecliptic parking orbit of size 170 into 36,500 km. The mission objectives of Chandrayaan-3 are to demonstrate safe and soft landing on lunar surface, to demonstrate rover roving on the moon and to conduct in situ scientific experiments. To achieve the mission objectives, several advanced technologies are present in landers such as altimeters, laser and RF-based altimeters, velocimeters, laser Doppler velocimeters and lander horizontal velocity camera. In inertial measurement, laser gyro-based inertial referencing and accelerometer package, propulsion system, 800 N throttleable liquid engines, 558 N altitude thruster and throttleable engine control electronics, navigation guidance and control, powered descent trajectory design and associated software elements, hazard detection and avoidance, lander hazard detection and avoidance camera and processing algorithm, landing leg mechanism. To demonstrate the above said advanced technologies in Earth conditions, several lander special tests have been planned and carried out successfully. Integrated cold test for the demonstration of integrated sensors and navigation platform test using helicopter as test platform. Integrated hot test for the demonstration of closed loop performance test with sensors, actuators and engines using tower crane and test platform, lander leg mechanism performance test on a lunar simulant test bed simulating different touchdown conditions. The overall specification for Chandrayaan-3 provided. Next, mission and live lander and rover. 1 lunar day means 14 Earth days. Landing site time 4 km into 2.4 km. Science payload. Radio anatomy of moon-bound hypersensitive ionosphere and atmosphere. Ramva, Chandra's surface thermophysical experiment, instrument for lunar seismic activity, laser retroreflector array, rover, alpha particle X-ray spectrometer, laser induced breakdown spectroscope, propulsion module, spectropolarimetry of habitable planet Earth. 2 module configuration. Propulsion module carried lander from launch injection to lunar orbit. Lander module. Rover is accommodated inside the lander. Mass. Propulsion module 2148 kg, lander module 1752 kg, including rover of 26 kg, total 3900 kg. Power generation. Propulsion module 758 watt, lander module 738 watt, waste with bias, rover 50 watt. Communication. Propulsion module communicates with IDSN, lander module communicates with IDSN and rover. Chandrayaan-2 orbiter is also planned for contingency link. Rover communicates only with lander. Next, lander sensors, laser inertial referencing and accelerometer package, Ka band altimeter, altimeter, lander position detection camera, LPDC, LHDAC, lander hazard detection and avoidance camera, laser altimeter, LASA, laser Doppler velocimeter, LDV, lander horizontal velocity camera, LHVC, micro star sensor, inclinometer and touchdown sensors, lander actuators, reaction wheels, 4 nose, 10 nms and 0.1 nanometer. Lander propulsion system, bipropellant propulsion system, MMH plus MON3, 4 nose of 800N throttleable engines and 8 nose of 58N throttleable engine. Control electronics, lander mechanism, lander leg, rover ramp, primary and secondary, rover ILSA, Ramva and chaste payloads, umbilical connector protection mechanism, X-band antenna. Lander touchdown specification, vertical velocity 2 meter per second, horizontal velocity 0.5 meter per second, slope 120. The objective of scientific payloads planned on Chandrayaan-3 lander module and rover are provided below. Radio anatomy of moon-bound hypersensitive ionosphere and atmosphere, Ramba, Langmuir probe LP to measure the near surface plasma ions and electrons density and its changes with time. Chandra surface thermophysical experiment to carry out the measurements of thermal properties of lunar surface near polar region. Instrument or lunar seismic activity to measure seismicity around the landing site and delineating the structure of the lunar crust and mantle. Laser retroreflector, it is a passive experiment to understand the dynamics of moon system. Laser induced breakdown spectroscope, quantitative and quantitative elemental analysis and to derive the chemical composition, infer mineralogical composition to further our understanding of lunar surface. Thanks for everyone. That's all for today for Chandrayaan-3 mission. Hope it will be a success for India and the world.